So hello. Uh, So welcome to my lecture video for uh, exam P1 for actual exam P1. So I'm Dr. Wang. So in this video, we will check a problem 56 to 65 from the sample problem. Okay. So from problem 56, it says uh, the loss x is for a uniform distribution. So loss is from 0 to 1000 uniformly. Okay. So we want to determine deductible. So where we should set the deductible such that the expected payment will be 25% of what it would be result with no deductible. So with no deductible, so no deductible is just equal 500, right? So mean for this uniform distribution is midpoint. Okay, so by now with deductible is the 25% of this. So 25%, so 25% of this is 125. Okay, so now the payment with deductible equal this 125, right? Okay, so we want to find this C. Okay, so we can find this expectation for payment. So payment here is 0. In here is x minus c, right? Okay. So there's payment e equal. So from 0 to c is 0. So forget this part. So from c to 1000, the payment is x minus c, right? And the then density function 1 over 1000, so dx. So we just let this equal 125. So for this integration, we use take this constant outside, and we use substitution. We say the x minus c, like x minus c equal t. So then x become from 0, t become from 0 to 100 or 1000 minus c. So t dt, right? So this equal half t square. Okay, so we do not have space, but at the okay. Let's say I finish it here. So equal 1000. So this integration half of this square. So we let this equal 125. So we can find this C. Okay. So for problem 57, it says this x is the cream size. This x has a moment generating function. So we have moment generating function is this equal, let's say 1 minus, okay, okay. So we know this landing variables moment generating function. So what we want to find? We want to find standard deviation. So to find standard deviation, we want to find variance sigma square or variance of this landing variable. So variance equal, we have this like mu2 minus mu square. Oh, we can have this ex square minus ex square. So this we can denote this as mu2 minus mu1 square. Okay. So from moment generated function, so how can you find mu2, mu1? So we call this the moment generating function, meaning from this function we can find a moment. Its first moment is just the first derivative. Second moment, second derivative. So let's say first moment like mu1, so equal first derivative equal mxt first derivative. So then we let the t equal 0. Okay, so we just use the derivative. So okay, so this derivative we can put this -4, right? So -4. So derivative is this t -5, right? Then multiply this derivative for inside, so 25 0, 25 0 0. So here is negative 25 0 0. So negative, so here become positive. Okay. Okay. So we can find mu1. So mu1 equal, we let the t equal 0. So this equal 4 times 2500. Yeah, 4 times 2500. So this is mu1. So mu1 actually equal 1 0 0 0 0. Yeah. Okay, the mu1. So what is the mu2? Mu2 is second derivative. So this equal this function find derivative again. So this equal 4 times 2500. Then this derivative times 5 -5, right? Then this -6. And then multiply another this. So this is another negative, yeah. So this become positive. So we know mu2 equals this. So here we can say this equal this multiply 5 multiply 2500. Okay. So this equal so we can say this is just, if there's 4 times this is equal. So let's say this equal, we just put this for this, you just 4 times this, then plus 1. Yeah, so this equal this plus 2500. Right? Now 5 times 2500, we just split it as 4 plus 1. Right? So then we can find sigma square equal v2 minus v1 square. So mu2 minus mu1 square is cancelled. So this minus this equal this. Multiply 2500, right? So then we can take square root. We can find sigma. So for this problem, also moment generating function. Yeah, so there's a problem about the moment generating function. So we have three variables, j and k, l. So their moment generating function like this. J's moment general function k or l. So let x represent the combined loss from these three. So this x just equal j plus k plus l. Okay. So we know moment generating function for x is the moment generating function, the multiplication for their moment generating function. So equal, so we can say equal 1 minus 2t. So this is -3, so this is -3. We just multiply together, so just put the exponent together, right? So this equal, it's moment generating function equal 1 minus 2t. So negative, let's say, here is 3, so 3, 2, 4, equal 10, right? Yeah, -10. Okay, so we want to find mu 3. So this is moment, so this moment. So mu 3. So mu 3 is just a derivative, so the derivative. So we need to find, let's say, so mu 3 is just equal to this. So the derivative. Then we let t equal 0. Okay. So we just check a first derivative, second derivative. So first derivative equal -10, then this -11, right? And multiply 2. So this equal like 20. 1 minus 2t -11. Then second derivative is 20 times 11. Or 20 times 11, then multiply 2. So 20 multiply 22. Then this -12. Okay, so the derivative so equal 20 times 22 times so 24, right? 24. Then this 1 minus 2t is -13. So we just check the value at the t equals 0. So this part equals 0. So we say this just equal 20 times 22 times 24. Okay. So for problem 59, we want to find the difference between 30th and 70th percentile. So what is a percentile? So we just say like, okay, so 30th percentile means like here cut off point A. So this part count for 30%. Okay. And B, there's B, so this part count for, let's say, this part cumulative function or cumulative probability 70%. So we call this cut point the 30th percentile, and this is 70th percentile. So we need to find this cut point. Okay, so let's find in general, let's say we want to find this cut point b x less than, let's say, less than alpha equals some percentage. So we just find this probability. Okay. So this probability is, let's say, so the density function x is larger than 200. So from 200 to alpha. And the density function is this constant. There's constant. So here is x 3.5. So dx. So 3.5 dx, another negative 3.5, right? So we can say negative 3.5 integrated is negative 2.5 and x negative 2.5. Okay, so integrated out is negative let's say x no, so this integrated out is negative 2.5. Then this x negative 2.5. So then from there's 2 points. Okay, like this, right? So x x 2.5 times this. So we just plug in. Okay, so this equal c is, so this become 200 square. 200 not square. This number is 2.5 power. Then multiply. So here and put a negative. Yeah. So smaller one is 200. So that's equal 200 2.5. So minus alpha 2.51. Right? Okay. So this so equal first one is just 1. So just equal 1 over, so here's alpha 200 2.5. Okay. So if this, so we want to find alpha such that this equal this number is 0.3 or 0.7. So we just find if this is point, so we want to find a, so a is 0.3. So this means this is 0.7, right? So we can find this alpha, and for b is this number is 0.3. So 0.7 become 1 minus 0.3. So we can find this alpha. This alpha is a. That alpha is b. Right? So let's say, can we get to this a? So we just take two. Let's say, so this one we just take 1 over 2's power. So this become 200 over alpha equal 0.771 over 2.5. So alpha equals as 200 over 0.7, yeah, 1 over 2.5. So we get this a equals as a equal 200 over 0.71 over 2.5. So same way, so this b is thus 200. So here become 0.3. 0.3 is this power 1 over 2.5 power. Okay. So use calculator, we can find a and b, then find their difference, b minus a. Okay. So for this problem 60, it says things that cost. We say suppose this x. Okay, its cost is mean is this, and the variance is this. So we know for this x, we have that information. Is x equal to 100, and Vx variance equal to 60, right? So now we put a 20% tax. Okay. So this we say cost become y. So y is equal added 20%. So that's equal 1.2x. Right? Added 20%. So what do you want to find? Find the variance. So find the variance for this y. So we just find Vy. Okay, so Vy equal V 1.2x. So this equal 1.2 square. So variance, we take a constant, we take square out. This constant should be square. Yeah. So Vx. Okay. So this equal 1.2 square times 260. Okay. So use calculator so we can find. Okay. Okay. And so this problem so 61 is exactly the same as the problem we discussed before, only changing this, right? Yeah. So this one, we do not want to repeat. So just like changing this to 200, I just here's 0.75, 0.25, so 1 over 2.5. This minus, I just changing this percentage to 30, 30 from 25 and 70 to 75. Okay, so this is the difference. D equals S, right? Okay. So for this problem, we know this x is cumulative function, not a density function. So from this, it's a cumulative function, we want to find the variance. So to find the variance, we need to know its density function. So here, the story is, so from cumulative function, we need to go back to density function. Then from density function, find variance. Okay. So what is the density function? So we only know it's a cumulative function. So cumulative function, let's say. So there's a cumulative function is just like that. When x less than 1, this is 0. Okay. And when x equal 1, from 1 to 2, from 1 to 2 is like it's a curve, okay, like a curve. Then when x larger than 1, larger than 2, so this become 1. So here we just need to check source ending those point 1 and 2 connected or not connected. So let's say when x, okay, when x equal 2, this fx, okay, when x equal 2, so I'm sorry, when x equal 1, what is f1 is? So f1 is, so according to here, so we should use this, right? When x equal 1. So plug in x by 1, so we find this equal, let's see, when x equal 1, 1 minus 2 plus 2, or half. Yeah, okay. So from here, so we can see this is 0. So from 0 to half, we have a jump. Just like that, have a jump. Okay. So this have a jump, so we know density function is at the x, density function at x equal 1, this equal half. Okay. So when x, so because we have a jump here, so between 1 to 2, 1 to 2 is its derivative, right? It's a derivative when x larger than 1. So there's a density function, it's a derivative for cumulative function. So this equal x minus 1, right? X minus 1. Okay. And so when x larger than 2, the density function equals 0. X larger than 2, larger than 2. So how about x equal to? When x equal to, so we will check have a jump. So x equal to, obviously f1 like left side, right side, so right side. So if when x equal 2, so on this side is 1, on let's say we use this notation, 2 plus right side equal 1. So how about 2 left side to negative? So for 2 negative, we just check this. So when x equal 2, so 2 square, 4 minus 4 plus 2 over 2 also equal 1. Yeah. So at the x equal 2, no jump. Okay. So we can say density function is like this. Density function at x equal 1, half. Then when between x from 1 to 2 is x minus 1. So once we have density function, then we can find variance. So let's say what is x? Okay, so x equal, so x, so here x equal 1, x equal 1, so probability half, plus, so x larger than 1, so from 1 to 2, so, okay, so from 1 to 2, this x times density function is x minus 1. Okay, density function is x minus 1, right? Okay, so we can find this. So then x squared. So x can be 1, this is half, right? So x squared is half. X equal 1, 1 square is half. Still 1. So then plus, so x between 1 to 2, 1 to 2 is, okay, so x squared. So that's the function x minus 1 dx. Okay. So this example is like from cumulative distribution function to density function. So if cumulative function continues, can do derivative, then derivative is a density function. But this is like a piecewise defined function, so we should be careful. So the jump is just the probability, right? From 0 jump to here. Okay. So from this cumulative function to density function. So from density function, so we can do everything. Okay. Okay. So for problem 36, we wanted to find the variance. So variance for y. So at first, what is y? So y is the age of machine at the at the time for replacement. So replacement is when the machine broken, or when the machine when the machine fail, we replace. And also when the machine is too old, we will replace, right? So this is why, so this is like will be replaced at failure or age 4. So we let this x is time age of failure. So the replace time y is minimum of x and 4, right? So suppose x, let's say, so x just from 0 to 5 here, okay? Okay, so if x happen here, like failure happen here, replace, right? So if failure happen here, replace is 4. Replace is just like this, and replace time is just 4. Okay. Okay. So find this variance of y. So we just need to find it according to definition. Just the variance is equal y square minus y square, right? So we need to calculate those two. So let's check ey. What is ey? So ey so equal if x from 0 to 4, this y just equal x. So then fx. Okay, fx dx plus so x is between 4 to 5. Saying this y is 4. Saying that's the function dx, right? So what is y square? So y square is let's say between when x between 0 to 4, this y equal x. So this equal x square fx dx. And plus, so here, when x between 4 to 5, this y equal 4. So y square equals 16. Okay. Right. So what is the density function for fx? We find fx is just the constant 1 over 5. So we just plug in 1 over 5. Then we can easily find this ey and ey square. Right? So here fx just equal 1 over 5. So plug in, so we can easily find those integration. So for this problem, we want to find the percentage of claim that those claims are within one standard deviation. So we find like claims. So at first we find one standard deviation of the mean claim. So let's say like a mean, like a mu, just like plus sigma, or mu minus sigma. Right. So we want to find such range in such range, how much percentage or how much probability for this interval. So here at the first we need to find the mean. Let's say what is the mu? So mu is just an average from two add them up divided by 2. Okay, I think this is 1. Okay, so there's 50, right? Mu is 50. Yeah. So then what is sigma? So we need to find sigma. Okay, so this sigma, we need some calculation. So what is let's say, so what is sigma or what is variance? Variance equal, so we just plug in this formula. So equal x, we can use this, minus x squared. So we know x this equal, we already defined this x is 50. So we just focus on x squared. So x squared, so here just use this calculation, right? X squared, so equal 20 squared times the probability. So 30 squared times the probability, like this, right? So here just some calculation until 80 squared times probability. Okay, so we can put this number into a calculator. So you should have a good calculator, like let's say like A2 plus. Oh yeah, you need a calculator to do those things. So you can find sigma. So then you can find, let's say, so sigma. So you can find this like 50 minus this sigma, 50 plus sigma. So you can find what range for this. So I think like this will be like maybe like in this range. Okay, so you can say 45%. Outside of 45% is inside 55%, like that. So for problem 65, it says this insurance policy has a deductible of $250. Okay, and the damage, the cost is uniformly distributed. So damage is between like damage is 0 to 1500. So okay, so deductible is 250. Okay, so what we want to find, find standard deviation. So this standard deviation, we need to just find the variance. Yeah, then take a square root, becomes standard deviation. So find the standard deviation of payment. So payment here is 0, here payment is x minus 250, right? So there's a payment. So we need to find variance of payment. So let's say variance. So let the payment is y. So we want to find Vy. So according to definition, Vy equals Ey square minus Ey. So minus Ey square. So here we just check, we need to find Ey and Ey square. So let's say Ey. So Ey equal, so from 0 to when x from 0 to 250, 0. So from here 250 to this, so when x from 250 to this y equal x minus 250, right? Okay, then the density function for x is 1 over 50. So dx. So this is Ey, right? So what is Ey square? Ey square. So here 0, forget it. So we say just like from 250 to this. So payment y square is just the x minus 250 square. Then density function is 1. Density function is this. Right? So just do the find those integration. So for here, for those integration, we use substitution and take a constant outside. So we, for example, here we can do this easily, right? Take a constant outside, and this equal t. So t squared dt. Then t. So t is x minus 250. So when x equal to 250, this t becomes 0, and then here become so when x equal 1500, then the t become 250. Right? Okay, so this we can easily define. This equal 3, so then 253 over this, right? So here I just use a calculate. Yeah. Okay. Okay, so this is a problem from I think from 55 to 65. Okay, so we can stop here and see you next time. See you next video. Okay.